Hello and welcome to lesson 2 in our series. In this video we're going to describe, explain, and sketch common 2D shapes. Here's our Georgia standard. We're going to find areas of right triangles and other triangles, quadrilaterals, and polygons by composing into square or decomposing into triangles and other shapes. We're going to apply these techniques in the context of solving real-world and mathematical problems. Here's our reference right here. And here's our Common Core standard, which reflects the Georgia standard. And again, my name is Bryce Hill. We're doing basic geometric shapes. This is our reference textbook. And we're doing that for Georgia State for spring semester. Here we have good old Bloom, who is going to help direct our learning. We began the first lesson with the bottom of the triangle, remember, where we had the students define and list the geometric figures. We moved on up into understanding, where the kids were describing and identifying geometric figures. And here we're at the middle of the triangle with apply, where we're going to have the kids sketch geometric figures. Here's our established goal. Again, we're going to describe, explain, and sketch common two-dimensional shapes. Now you may use a plain sheet of paper, PowerPoint, Google Docs, or any software that will allow a student to create images on documents for the student to explain, sketch geometric figures by definition, labeling, illustration, or by symbols. Barriers to goals. Students may not be able to access computers, Microsoft Office Suite, Google Docs, or other software. The main objective, students are to explain the terms and sketch the components of the most common two-dimensional shapes. Secondary objective, students may become familiar with the quadrant setup of the Cartesian coordinate system. Here's an example here. Now you don't have to use this setup. You could just use a plain sheet of paper if you would like. Transference. Students will be able to independently use their learning to identify, construct, and deconstruct more complex geometric figures. Understandings. Students will understand that geometry can effectively describe naturally occurring patterns. Students will understand that identifying the properties of smaller components of geometric figures can help understand the composition, design, and properties of more complex geometric figures. Students will understand that sketching of one geometric figure can be used to generate another. Students will understand that there is more than one way to represent and understand relationships between geometric figures. Essential questions. Students will keep considering the concept of why lines continue towards infinity in both directions. Students will keep considering the concept of why rays continue towards infinity in one direction. Students will keep considering what are the defining relationships between a point, line, line segment, ray, or angle. Students will keep considering what tools can be used to measure line segments or angles. Students will keep considering why it is that we can measure line segments and angles but not lines and rays. For knowledge, students will know that lines and line segments are made up of at least 2 points. Students will know that rays are identified by their endpoints. Students will know that lines continue towards infinity in 2 directions. Students will know that rays continue towards infinity in 1 direction. Students will know that angles are made up of 2 rays that share an endpoint. Students will know that line segments, lines, rays, and angles make up more complex geometric figures. Students will know that acute angles are less than 90 degrees, right angles are 90 degrees, and obtuse angles are over 90 degrees. Skill. Students will be skilled at identifying the components that make up complex geometric figures. Students will be skilled at sketching line segments, lines, rays, and angles. Students will be skilled at identifying a line segment, line, ray, or angle by definition, labeling, illustration, or symbols. Students will be skilled at measuring line segments and angles with a protractor. Students will be skilled at identifying an acute angle, a right angle, and obtuse angle. Students will be skilled at identifying the symbols that designate a right angle. Differentiation. You can differentiate this lesson by having students recreate their sketches using Microsoft Office Suite or Google Docs through an engineering design challenge. Engineering design challenge, we have them design a document, image, or slide presentation that can be used to explain or sketch components of common 2D shapes. Now on to the lesson. To begin, draw a geometric figure that connects point Y and point Z. Label that figure line segment YZ. Practice drawing the same figure in different orientations in the remaining quadrants, labeling the figures YZ with a line across the top. How will we draw a line that connects point A and B differently than a line segment? Here we have our line segment. What we would do is we would extend the ends and put arrows notating that they continue on in both directions. Label the figure AB with a continuing line across the top. Can a line have more than 2 points? Explain. Have the students practice drawing lines that have more than 2 points and label them. Here we have a line that has 3 points. Notice the labeling, line A, B, and C, representing all points. Here we have a line that has 4 points. Now notice that we label it as a line continuing called AD. You can let the students know that all they have to do is identify 2 points on the line, or they can name every point on the line. It's up to them. Draw a geometric figure that begins at point W and passes through point X onto infinity. Label the figure ray WX. Draw a ray that begins at point X and passes through point W. Is ray XW same as ray WX? Please explain. We want the kids to understand that since these points are different for each ray, then they are different ray. One is ray XW, the other one is ray WX. So these are 2 different rays. Practice drawing the same figure in different orientations in the remaining quadrants. Label the figures with this ray illustration. Make sure the students understand that when they're labeling rays, they have to label the endpoint first. Now we move on to angles. Now we want the students to understand that angles are made up of 2 rays that share the same endpoint. Here's our protractor. We're going to show the kids how to use a protractor to draw straight lines and angles. The protractor should have holes in them where you can have your beginning point, as so. And here's the other point. You need 2 points to create a line segment. Now we're going to line this up, and we're going to create our base ray. We're going to connect that. We're going to put an arrow on it to indicate that it continues to keep moving on. That's 90 degrees. .90-degree angles are indicated by having a box in the corner. Now we're going to keep this as a reference angle, and we're going to draw a few more angles. Using your protractor again, we have our base angle, and we're going to keep the 90 degree as a reference angle, but we want to try to draw other angles using the protractor. We're going to go 45 degrees. This part right here is 45 degrees. We're just going to mark off here, let you know that this is the angle that we're discussing. Any angle less than 90 degrees is an acute angle. Now let's do one more angle. We're going to keep these other reference angles here. Now we want to draw 100 and I think it was 25 degrees. These are reference angles, and knowing that the bottom part are for the lower angles, and then it goes on to higher angles. So here we're going to go at 125. We're going to put our point here. We're going to connect that point to our end point, which is here at the base. Ignoring all the other angles, from this point from the base over here is 125 degrees, and that is an obtuse angle because it is greater than 90 degrees. To end the lesson, you can evaluate the students by collecting their sketches and seeing how well they did. Here's our cited reference material. Check out the other videos we've made in this series and have a nice one. Thanks.